This is going to be a quick demo of writing Python code and running it using a Jupyter notebook in your browser. So the first thing that you're going to want to do is navigate your web browser to jupyter.org. And when you land on jupyter.org, if you scroll down a little bit, you're going to run into this page about the Jupyter notebook. And one of the options is to actually try it in your browser. So go ahead and click that tab to try it in your browser. And so this is going to launch a little menu where you can start a new session. So if you'll see this button in the top right corner that says new, you can open a new Python session. And actually you can see that there's quite a few other supported languages that you can run on their servers. So okay, so once you've got this Python session, then you can go ahead and basically just start writing your code here. So you can import libraries. So I'm going to try to import a couple libraries. How do I want to do this next thing? Okay. I always have a hard time with the syntax for, so these are two different libraries that are pretty useful. NumPy has a lot of numerical computing tools built into it, a lot of math tools built into it. Matplotlib has some plotting features built into it that are pretty nice. So okay, so you can import these things. Let me just make sure I've imported everything right. Okay, so if you want to run your code, you can do it in a couple different ways. You can either type Shift-Enter in the keyboard, or you can also click on Run. Okay, so I'm not getting any errors. So let me just really quickly just do a couple of different things. I'm gonna basically plot a really simple function right now. So I'm gonna use the array function np.linspace. This is one of NumPy's member functions. Let's see. So a really common thing that we're going to be doing is plotting these particle in a box energy eigenfunctions. So let's go ahead and make an array of x values between 0 and L, where L is equal to 500, and we'll have 2,000 such values. And let's go ahead and make y equal to the first energy eigenfunction. Okay, and so basically this line right here is going to create an array of x values between 0 and L, and how many values will it create? 2,000, so the spacing is going to be L over 2,000. And then np.sign, given the argument of the x array, is actually going to evaluate sine of n times pi times each x value divided by L, so it's actually going to return an array of y values. And so here we have properly normalized first energy eigenfunction because my n is equal to 1 here. Okay, so if you want, you can print out these values. You can print out the whole arrays if you want. So this is going to be gigantic, but here we go. And it goes on forever. Go. So we printed out both x and y. But what do we really want to do? We really want to plot them. So I'm going to use the pyplot function to create a plot object. And then I'm going to actually show the plot object. So this is going to plot x as the x-axis, the values of x as the x-axis, the values stored in the y array as the y-axis, and it's going to plot this whole thing in red lines. So let's go ahead and see that. So there we go, the first energy eigenfunction. Let's change that to the third energy eigenfunction. Run the code again, get a new plot. We could always define the probability density function as y times y. These are real functions. I don't need to take the complex conjugate. And there we go. Oh, sorry, P. There we go. And you can do anything you can do in Python in these things in principle. So let's actually go ahead and define a little function. This is a function that we'll be using anyway. I'll call it PIB func, and basically it's going to take quantum number n, array of x values x, and the length of the box L, and what will it do? It's going to return an array of values of the energy eigenfunction with associated quantum number n. So So we can actually replace this line right here with that function call. And I just need to make sure I define my quantum number n up here, so let's do that. N equals, I feel like plotting the fifth energy eigenfunction now. And there we go. The probability density, so this function call returns energy eigenfunction 5. Then we go ahead and compute the probability density function from y times y, and then that's what we're plotting is the probability density function. So it's a brief tutorial of how to use Jupyter to write and run Python code in your web browser.